Good afternoon, everyone. As Devin said, I'm Nico Acosta. I'm the Director of Product for Programmable Voice. This is my colleague, Torkel Dominique, Technical Lead for Programmable Voice Core Infrastructure. Every code at Twilio passes through Torkel's code. So, no pressure. Earlier today, we saw from Kedar how to architect voice applications. We then saw how to build advanced multi-party call flows. In this session, we're going to be covering scaling your voice applications. But not only that, we're going to be covering how to scale without pains. And we're going to do that by sharing some of the lessons that we've learned scaling Twilio and how you can apply them to your voice application. So 4 years ago, when Torkel and I joined Twilio, our growth looked something like this. And over the years, we went from this, to this, to this, to this. And as you can imagine, we've hit a series of scaling challenges as we've scaled up. Like, you can't even see the small blips from a couple of years ago. The first challenge that we hit was how to move fast without breaking things. Jeff talked this morning about agility with reliability. So when you think about voice applications, voice as a communication is critical. Voice applications can't fail. We can't have maintenance windows. And every blip in a voice application is noticed. But as product companies, we want to continuously ship new features. We want to be able to roll out those features however we want and control when we put those features in the hands of our customers. But when you look at a kind of traditional Agile team in 2 or 3 week sprints, it looks something like this. At the end of every sprint, you deploy. That leaves you with one window to do a marketing launch that is aligned with your sprints and with your deployments. This model has one problem, and it's like a rocket launch. It's kind of like an all or nothing. It accumulates a lot of risk. It accumulates all the risk of 2 or 3 weeks worth of code. It's an all or nothing, and then if you miss the entire sprint. At Twilio, over the years, our sprints look more like this. We build and deploy in very small increments of code. That's why we have the thousands of deployments that Jeff talked about this morning. But most importantly, we also have the flexibility to choose when do we launch those features. So we've decoupled 3 concepts that are completely independent. Marketing launches from sprints, from deployments. And to talk a little bit more about how we do this, I'm going to pass it on to Torkel to do the technical deep dive.
Thanks, Nico. So I just wanted to start by showing you this this picture, which I'm sure some of you have seen before. I just think it's really cool. And it really illustrates well what we're doing when we deploy to production, every time we deploy. Because like Nico just said here, in telco there is really no downtime. There's no maintenance window, right? So we have to essentially lift the hood and start replacing components while we're driving the car, basically. That's really what we're doing. And that's challenging, but it's also very risky. So I'm going to talk about those risks a little bit and what we do to try to reduce those risks. First of all, of course, before we even think about deploying to prod, we go through rigorous testing in our development and staging environments. We do all kinds of load tests, functional tests, regression tests, resiliency tests, failover tests, all those things. And when all that passes, then and only then we go to production. But even though these tests pass fine, there's still somewhat of a chance or risk that bugs slip through or other things go wrong when you deploy. So we need to have some more tools to reduce that risk. And here are 3 techniques that we're using when we deploy features to production. Shadowing, which I'm going to start by talking, and then Canary deploys and account flags. So let's start with shadowing. Let's imagine that you have a service that reads something from a database, let's say. And you want to replace this database with, or rather, you want to put a microservice in front of the database to decouple the service from this database. To do that, that's a very risky deployment because all of a sudden this data takes a different path. It can change. When you get the result, it might be slightly different in different format and so on. So things can break. Even if you tested it in your staging environment, there's still a chance that certain corner cases, the data is different and so on. So to reduce the risk, we do a 2-step deployment. We start by first deploying a new version of the service, which does basically the same thing as before. It reads from the database, but it also reads from in parallel, sends requests to the microservice and gets the data from there. And then it compares the results from the two. And if anything is different at all, we'll just log something, an error, or send an alert or something. But then we continue with the old data, the data we got from the database, because that we know for sure works, because that's the same as before. So essentially, the experience for the user will be exactly the same. There is basically no risk in doing this deployment because we're not using the new data. We're just verifying, basically. We run this for some time so that we can gather data and make sure that we don't have any of these discrepancies between the two. When we're confident we had this in production for maybe a day or two, or more, depending on what the risk is, then we do step number 2, which is the next version of the service. This time, the service will remove the connection to the database completely and only read from the microservice. This is a very, very powerful way of reducing the risk for this type of infrastructure change in the backend, changing databases and services and so on. But most deployments are not really applicable for this. If you just do a regular bug fix or some code change in a component, there is not really anything to shadow, right? So what we do for most of our deployments is what we call Canary deployments. It's not the bird. It's not the islands outside Africa. This is really, it's a single host that we deploy in a cluster of hosts. That single host has a new software version that we want to deploy. We run this host for some time, perhaps 10 minutes, an hour, a day, or several days, depending on the risk. This gives us the chance to monitor this Canary, this new code, very closely. We can compare log files with the rest of the cluster. We can use our metric system to basically do overlay graphs with the Canary metric on top of the average of the other hosts, for instance. That way we can monitor things like CPU, response times, memory, and so on, and see, is there any difference here? Have we introduced anything that could potentially be a problem? And so that's the yellow little canary there. If you have a big cluster, then you can actually take it one more step and deploy a group of canaries, which gives you a little bigger footprint, so you can collect more data. So if it's a high-risk deployment, we do that just to be extra careful and make sure that we can catch any problems before it will affect everybody. So this is still a very small impact to users, to customers. When we run this for enough time that we're confident with this, we'll do the full deploy. So there are situations, though, when you have a much more complicated deployment to do. Perhaps it's a new feature, or maybe it's a big structural change, refactoring, some kind of really risky big change that you're doing to your system. And in this case, a normal Canary deploy just isn't enough. It doesn't give you enough time to really make sure that we're safe to deploy. To get around that, we can use account flags, which lets you basically choose different code paths based on a flag on a per account basis. So essentially what you do is you deploy a full deploy of your new software, which is risk-free because the new code will only be behind the flag. So only if this flag is enabled, the new code will be executed. And initially, you will just enable maybe internal accounts, your employee accounts, for instance, which are safe to do. You can run this for a long time, for weeks or for months even, and gradually roll it out to customers. What you also can do is make sure that your end-to-end testers, your automated tests that run in prod have this flag enabled so that they will fire off if something breaks right away. And now I'm going to hand back to Nico, and he's going to talk about some cool stuff and maybe do a demo.
Yep.
Hopefully.
That's really cool, Torkel. Thank you. So account flags are a gradual rollout technique. So I'm going to talk about how can you do a gradual rollout technique with a contact center. So imagine you have customers calling in a Twilio number, 1-800-GROWTH. We webhook out to your server, fetch some TWIML, and then on the other leg you have the agent answering that call in a WebRTC browser. Super simplified implementation of a contact center. But what if you wanted to deploy a new agent experience, right? On one hand, you have a set of nodes with your old version or your current version, and then you have a new set of nodes with your new version. The big question is, what do you do now? So we're going to walk through how to do gradual deployments using an AWS Lambda function. That's a micro execution environment that's going to hold the logic of that gradual rollout. And we're going to send 20% of traffic to the new version and keep 80% of the traffic in the existing version. It's going to work something like this. Twilio is going to webhook the Lambda function. The Lambda function is going to have the gradual rollout logic. It's going to return an HTTP 302, which tells Twilio, redirect this request either to the new version or to the old version. And Twilio is just going to follow that redirect. Make sense? So going to jump here. This is the Lambda function. The first thing I'm going to do is bring the number down from the parameter. In Lambda, parameters come in the event. Here I'm going to do things slightly different. I'm not going to use the account as the rollout cohort. I want to use the number. So one of the things I want to do is that if you call twice, you get the same experience, right? So I'm going to use the number as our cohort to figure out where to send you. So we're going to create a rollout cohort, and then we're going to take this number, and we're going to use the last 2 digits of the number to figure this out. And we're going to turn this into an int. So if the rollout cohort is less than 20, return. So this is going to be the new experience. And we're going to return a location that this Lambda function is configured to return in the 302 in the header. And I'll show you where we get that location in a second. And this is the current version. So I go to my, my console, and we have two TWIML bins, one with the new, one with the current one. So let's go with the new. We should get this with 20% of customers. So we're going to put this one here. It's looking good. And the current one, 80% of customers. And we're going to put this one here. We can test our function. Just copy it in case something weird happens. So everything's looking good. Now in this phone number, I have that Lambda function configured.
I'm going to grab my phone.
So if you guys give a call to the number 415-727-7589.
Hello, this is the current version of our contact center that 80% of customers should experience.
Cool.
Okay.
Who got the new version?
Ah,
Who got the current version?
sweet.
Nice. Yes, it has to be wired up with the API gateway. Cool. So that's a very simple way that you can leverage the gradual rollout techniques with your Twilio application. You point Twilio to a Lambda function, and then in the Lambda function you choose, you have logic that tells Twilio to redirect. Next, we're going to talk about our second scaling challenge, data persistence and failover. So data persistence is the hardest technical problem that any software as a service company fails as if that any software as a service company faces as a scale. And it pretty much boils down to this. You have your application in one data center, you want a failover infrastructure in a secondary data center, and this looks easy. The big question is, what do you do with the database, right? That problem is not that easy. At Twilio, after many, many years of thinking about this problem, we came up first with the different use cases for the data. We figured that not all the data was equal. So first we have configuration data. That's like all the account, all the number. It doesn't change that much. Then we have in-flight data. That needs to be very quick, very fast. Reading and writing changes a lot. And lastly, we have post-flight or analytics data that once it's written, it kind of stays there forever. So I'm going to pass it to Torkel to talk a little bit about how we solved these three types of data challenges at Twilio.
Thank you. So we at Twilio, we like to keep things forever. We're like hoarders, kind of, but for calls. For call states, and that's really cool, I think. But it creates a problem for us because there is this little thing called the database, where we store all the calls, and that is going to start growing and growing and growing forever, basically. This is a scalability problem, basically. And like Nico just said here, we had to sit down and figure out what to do about this. And we identified these 3 different categories. I'm going to go through them now a little more in detail. The configuration data, that's really very static data. It doesn't change much. It does change once in a while when you update your account, but it's essentially static. But you need to read very fast. An example of this is account information, right? Your voice URL that we configure and account flags and so on. In-flight data is very different. It's something that changes a lot. We read and write very fast, very frequently. It's a pretty contained volume because it's only the calls that are in-flight. That's essentially what it is, in-flight calls. And the last category is post-flight data or analytics. An example of that is the call information after it's done, right? And the post-flight data, on the other hand, just keeps growing. It grows and grows, but it never changes. It's static. It's immutable, basically. It also doesn't matter too much if the reads from post-flight is not instantaneous because it's used for analytics and post-processing, basically. So we realized it became apparent that we have to split these 3 things into different storages because it just didn't scale as one database. So what did we do with these different data? The first part, the configuration data, such as the accounts, they, as we said, they're read heavy. We have to read them fast because every time we process a call, we have to read them, right? So it's very read heavy. But since it doesn't change much, it's also very suitable for caching. So we can cache all the accounts, and we can also cache them near the system we're in. So we're in a distributed environment, right? So we have data centers in Europe and in US and all the other regions. So we can have a cache in each region, which makes it really fast. The next category, in-flight data, is very different. So here we can't really cache because it changes so much. But we have to be able to read and write very fast. And to do that, the best type of storage is something that's stored in memory. An in-memory database of some kind, a distributed in-memory data grid, something like that, which also usually gives you very good HA capabilities. It has built-in, typically, replication and repartitioning and so on. So failover happens very fast. And it's also short-lived data, which means that it doesn't grow so much. You can fit it inside memory storage. And we don't have to replicate it across the regions, right? Because if, let's say, the US region fails, God forbid, then that call is over anyway. So there's no point in trying to replicate that data. It builds up again the next time you dial in. And then the post-flight data. This is the massive data volume where we need a cheap memory. And here, the traditional disk space storage is more suitable. What we do from the in-flight data, a call record typically when it ends, we have to send it over to the post-flight storage. And that we can do asynchronously. It doesn't have to be instantaneous. And so with that, I'll hand back to Nico.
Thank you, Torko. So let's look at how this would look like in a call tracking use case built with Twilio. For those of you who are not familiar, call tracking in its simplest form, you have on one hand a Twilio number that identifies where the customer is calling from. So you can imagine a billboard with a Twilio number that forwards to the number, like the real business number. And the whole thing is that you can count how many calls are made to each number. So you can measure the effectiveness of your offline advertising. So call tracking has two characteristics. One, that you need configuration data. If you handle a little bit more complex call logic, you will need in-flight data, and then you need all the analytics where you count all the calls. So in a high availability scenario, you would have something like this. You have your primary infrastructure in one data center where you point the Twilio callback URL, and then you have your failover data center where you point the fallback URL. Once we make a request to the callback URL, if that fails, we will go to the fallback URL. All that is good, but it has the same problem that we talked about earlier and that Torkel talked about. What do I do with my database? So if we apply those same principles that Torkel talked about to this call tracking use case, it would look something like this. So say you have a US East and a European data center. The first thing you'd have is your configuration data. You can have your configuration data in the US that is eventually consistent with the data in Europe. It doesn't change that much. And eventually consistent means that it will eventually be consistent. So it doesn't matter if it takes a couple of seconds for the phone number mapping to replicate across region, because it doesn't change all that much. You can use something like Cassandra, like DynamoDB, and then you can cache heavily in each of the regions. With the in-flight data, as we learned from Torkel, we don't need to replicate it. If one region fails, the call is going to go entirely to the other region anyways. But that's a much smaller data set. So you can have an in-memory data grid, or you can have like a MySQL HA cluster for in-flight. And then for post-flight, you can have an asynchronous data pipeline architecture. You don't want, one thing that you don't want to happen is the analytics queries on your database that can be very heavy, breaking your in-flight read requests, right? So you want to decouple those, make the post-flight async, throw it into a Kafka stream, throw it into a Kinesis stream, and have multiple consumers to a MySQL database, to an Elasticsearch cluster, whatever you need to do all the counting and reporting. So this way, we see how, for a call tracking use case that is somewhat simplified, but we can separate those three categories of data, and we can apply the right technology to each of the layers. So before we leave, three takeaways. The first one, deployments don't have to be like rocket launches. With software, you have the ability to deploy incrementally, to deploy in very, very small pieces of code. It doesn't have to be a null or nothing. Not all data is created and read equally. Really think hard about the requirements around the data and split them. That will help you scale. And then simple architectural decisions early on can save you a lot of growing pains going forward. My name is Nico Acosta. This is my colleague, Torkel. We'll be outside, and we're happy to take any questions.